Hey there folks, Steve the Math Buddha here. Welcome back to my channel. In this next video of my SAT prep series, I'm going to be showing you how to determine the number of solutions to a pair of linear equations. Now let's bring up all the questions that I found on this topic. Note that the questions highlighted in yellow pertain to the material that we're going to be learning today. The other questions pertain to the topic of slope, which I taught last week in part 1 of this two-part review. Note that the questions on this list comprise almost 6% of the math questions being asked on the SATs, and my video today will be super exam focused. We're going to get a really good handle on what questions are being asked and how the questions are going to be phrased. I really want you to walk away from this video being ready to handle any questions that the college boards might throw at you on the topic of slope and how many solutions to a pair of linear equations. In fact, if after watching this video and last week's video, you still have any issues with any of the SAT questions that are being asked on this topic, please let me know in the comments or reach out to me at stevethemathbuddha@gmail.com and I will do my best to answer your questions. Now, if you missed last week's video, I strongly suggest that you catch it before you watch this week's video, because you know what? In order to determine the number of solutions to a pair of linear equations, you have to be able to find the slope. So you really need to check out part 1 of this two-part review. And you can find a link to part 1 right here. And with that, let's move on to our review. Okay, so let's start with the y equals mx plus b case. If we have a system of two linear equations and both equations have the form y equals mx plus b, then it's really easy to determine how many solutions there are to the system, because there are only two parameters, the coefficient of x, which is m, which is our slope, and the constant term b. Now keep in mind, when we're looking to a solution to a system of equations, we're looking for a solution that solves all equations in the system. So in order for our pair of equations to have no solutions, if they're on the same coordinate plane, well, they have to be distinct and parallel lines. They have to have the same slope, but they have to be different equations, which means that our coefficient of x has to be the same, but the constant term b has to be different. Now, if our system of equations has infinitely many solutions, then our two lines must be the same. Then every point on the line would be a solution, which means that both parameters have to be the same. Our coefficient of x has to be the same, and our constant term has to be the same. If either of those terms are different, then our equations will represent different lines. That's true, again, because we're using this simple form y equals mx plus b. Now, our third possibility is that our system has exactly one solution, which means that our lines must cross at a specific point, which would happen if the slopes are different, which means all we have to do is look at the coefficients of x. If the coefficients of x are different, then that means our system will have one unique solution. So let's take a look at an actual example from the May 2021 International Exam. We're looking at question 427. For this question, we're given a linear equation, y equals 1/2 x plus 5, and we're told that this equation is one of two in a system of equations. If the system has no solution, what could the second equation be? And we're given 4 possibilities, and we have to determine which one of these equations, in conjunction with our original equation, gives no solutions. And we just saw the rule. The coefficient of x has to be the same, but the constant term has to be different. C is the answer. If b was the second equation in our system, then that would mean that our system has infinitely many solutions because it's the same line. The coefficient of x is the same, and the constant term is the same. If either A or D was the second equation in our system, that would imply that our system has a unique solution, because in both cases, the coefficient of x is different than it is from our original equation. It's that simple when our equations all have the same form, y equals mx plus b. But of course, the SATs are never that simple. They love to throw variations at us. So let's take a look at this variation. Suppose instead of giving us two linear equations, they give us two linear expressions on the opposite sides of an equal sign. Well, you know what? That doesn't change our answer. Setting two linear expressions up equal to the same variable y is the same as setting them up equal to each other. The rules are the same. In order to determine the number of solutions, we first have to look at the coefficient of x. If they're different, then there's going to be one solution. If they're not different, then we have to look a little further at that constant term. If the constant terms are the same, then we have infinitely many solutions. If the constant terms are different, then we have no solution. So the rules are the same for this example as they would be for this example. Now let's look at a concrete case from the March 2020 exam. Okay, I'm going to have to cut in here because I really need to remind you to please like, share, and subscribe and turn on those notifications. I also wanted to share with you this amazing new design that I just got from my Fiverr artist. Check it out. This guy just knocks out one amazing design after another. I love this artist. And as usual, I have a link to his Fiverr page in the description below, along with a link to the Zazzle website where I had these designs printed. Now that's for original designs only. Math Buddha t-shirts are not currently for sale. But if you're going to buy anything at either one of those sites, please use my links because it helps to support my channel. And now back to our show. Let's take a look at this question from the March 2020 exam. It's question 429. Now this one is just a little bit different than the example we were looking at before because, number one, they're not asking us how many solutions there are to this equation. They're telling us that there are no solutions, and they're asking us what the parameter k must be in order to make that true. Another difference is that the expressions on either side of our equal sign do not quite have the form mx plus b, which means we have to do some manipulation to get them into that form. So let's do that now. On the left-hand side, let's distribute that product. When we multiply 1/3 by x, we get 1/3 x, and then we have to subtract 1/3 times k. So we get this. Now on the right-hand side, we don't have a constant term, but that's okay. That just means that the constant term is 0. So let's plug that in. Let's write it this way. So now that we have both sides in the form mx plus b, we could just go straight to our rules. In order for this equation to have no solution, we have to have the coefficient of x the same on both sides, which means that we must have k equals 1/3. Now we also have to have the constant terms different, but we don't actually have to check that because our answers are all numbers, and k equals 1/3 is the only answer that works. Now if we check our constant term, we will see that they are different. If we plug in a 1/3 for k, on the left we have the constant term, negative 1/3 times 1/3 equals negative 1/9. And on the right-hand side, we have the constant term of 0. So the constant terms are different, but we really don't have to look at that when the question is in this form. Also, I do want to point out, when I talk about the constant term, I'm talking about the term b from the expression mx plus b. So we're talking about this term. We are not talking about the constant k that is referred to in the question. So that's how we tackle our mx plus b questions. Next, let's take a look at our ax plus by equals c questions. Now we learned in part 1 that if the equation for our line has this form, then the slope of that line is going to be negative a over b. So if we have two lines in our system and each of them has an equation of this form, the way to determine if the slopes are the same is to look at the relationship between the coefficient of x and the coefficient of y. If the relationship is the same, then that means the slopes are the same. If the relationships are different, then that means the slopes are different. And the easiest way to determine if the relationship of coefficients are the same is to set one of the coefficients equal. So what we have to do is multiply one of our equations through by a constant in order to set the coefficients of x to be exactly the same. Once we have the coefficients of x the same, then we look at the other parameters to see how many solutions there are to our system. If the coefficient of y is not the same, but the coefficient of x is the same, that means that the two lines have different slopes, and that means that we're going to have exactly one solution. If we have the coefficients of y the same and the coefficients of x the same, that means that the two equations have the same slope, which means that we have to look a little bit further to determine whether we have no solutions or infinitely many solutions. What we have to do is we have to check that constant term to the right of the equal sign. If the constant term is the same and the coefficients of x and y are the same, then we have exactly the same line, which means we're going to have infinitely many solutions. If the constants on the right of the equal signs are different, but the coefficients of x and y are the same, then we have the same slope but different lines, which means we have distinct parallel lines. We're going to have no solutions. Now let's take a look at a concrete example. So here's a question from the April 2022 school day exam. It's question number 415. And in this question, we're given an equation, and we're told that it's one of a pair of equations in a system, and that the system of equations has infinitely many solutions. And we have to find the second equation. Now, right away, we see that equations C and D both have 2 for the coefficient of x, which is the same as our original equation. So we can apply our rules right away. When we look at equation C, we see that the coefficient of y is also the same, but the constant to the right of the equal sign is different. So C is not our answer. When we look at D, we see that the coefficient of y is different than our original equation, but the coefficient of x is the same. So D is also not our answer. Now we see that equations A and B have 4 for the coefficient of x, so we want to multiply our original equation by 2 so that we can match up the coefficients of x to the equations in A and B. And when we do that, we get this. So we see now that A has to be our answer. When we multiply our equation by 2, we get exactly the same line as shown in A. They are the same line. If A is the second equation in our system, then this system has infinitely many solutions. And that concludes our 2-part review on the topic of slope and how many solutions to a pair of linear equations. Please let me know in the comments if I helped you to answer the questions on this topic. If not, let me know why not. What could I do better? Again, if after watching this 2-part review you still have any problems answering any of the questions on this topic, please let me know in the comments, or reach out to me at stevethemathbuddha@gmail.com, and I will do my best to resolve any issues that you might have. And with that, let's take a look at last week's error challenge. Last week I left you with the following error challenge. This week we have another changing text situation. Let me know in the comments if you noticed this one. So where was this mysterious changing text? Well, let's take a look at 705. Notice how the text is not lined up really well on the right? In particular, take a look at that XY. Now let's take another look at 715. See how much better the text lines up, in particular that XY text? So that was last week's error challenge. This week I don't actually have an error challenge, but that doesn't mean that I didn't make any errors. If you see something, say something. Let me know in the comments. And that's all I have for you folks today. This is the Math Buddha signing off. Have a great night and have a truly pleasant tomorrow.